In the previous video, I had a question that was why we have three strings or wires each pulled by another instead of having a possible simpler arrangement like this where the spring directly pulls the heated up wire and the wire is directly in contact with the pulley and the pointer arrangement. And after a bit of thought, I have come to an possible explanation which I'm going to share with you, and you should think whether it's correct or possible explanation or not. So I guess this is actually to magnify the motion or deflection of the pointer. What I mean by that is that if this wire is heated up by some amount, say the temperature changes by some amount delta T, then there will be a increase in length of this wire which I call say as delta L. If L is the actual length or say 2L is the actual length, if this is the midpoint, so this length, let this length be 2L, then delta L as a fraction of 2L will be very small, and then to get a larger amount of length increment, I need this length to be very long. So what I mean is that this factor delta L by 2L, which is the increment in length by the initial length, is proportional to delta T. So if delta T is constant, and then to have larger change in length, I need a larger initial length that will make this device quite voluminous. So what I can do, I can possibly make an arrangement like this, where this hot wire passes round a number of pulleys so that the total length is quite long, and then one end is attached rigidly to the instrument and the another end is pulled by a spring. Then this might help. But there is actually a better solution to this than having a longer length, and the solution is as I shall be discussing now. See, this is L or 2L. So half of it is L, and so this point is attached to another string, say which is pulled by a spring. Then as it hits up, it will come down like this, and so this will be the amount of movement which I denote as x. This length, which is half of the length of the wire, is L, and this length, this hypotenuse, is L plus delta L. It's not L. Sorry, it's not L plus delta. It's L plus delta L by 2, or then let me just call that the increment of the length is 2 delta L. So initial length is 2L, and increment is 2 delta L. So this is L plus delta L. Now I want to compute what is x as a function of L and delta L. Now I know that x square is equal to L plus delta L square minus L square, so which is equal to L square plus 2 delta L times L plus delta L square minus L square, and so L square cancels, so this is equal to, it's roughly equal to 2L delta L, because this quantity is close to 0. This is delta L itself is very small, so the square of it is very small. So this is the this is equal to x square. So that means x is approximately equal to root over 2L times root over delta L. Now assume that say the value of delta L is let's assume the value of L is 100 unit and delta L is 1 unit. Then if I had this spring connected directly to it, then the movement of this point would have been delta L, which is 1 unit, which was 1 unit. Now in this arrangement, the movement of this point is delta x, which in this case would be root over 2 times L, which is 100, times root over delta L, which is 1. So this is equal to 10 root 2, which is roughly 14 point something, times 1. So I have a move x equal to approximately equal to 14. So I have a large magnification of the motion by this arrangement. And now instead of putting this spring here, if I connect it through another string and then to the spring, then you can immediately recognize that this will further magnify the motion of the spring. So that's the purpose why we have such a apparently complicated arrangement. It's because to increase the deflection of the pointer.